Proving trigonometric identities. Such an interesting topic. But let me explain what we're trying to accomplish when we're trying to prove trigonometric identities. Let's just imagine that somebody suggested that they had a lot simpler formula for a certain trigonometric expression. And they wanted you to use it instead of your equation that you'd come up with. Well, you'd want to know it worked. You'd want to know it worked all the time, that it was perfect. Well, that's proving trigonometric identities. We want to prove that some other expression is exactly the same. So an identity is a statement of equality that is true for all values of the variable. For example, 3x plus 2x equals 5x is an identity. That's always true. No matter what x value you use, 3x plus 2x is always equal to 5x. There's no tricks, there's no way to get around that. The equation 3x equals 15 is not an identity. It's not always true. Or sorry, it's true only for x equals 5. Only if you use x value 5 is 3x equal to 15. So this is like sometimes true. If x equals 5, it's true. Whereas 3x plus 2x equals 5x, that's always true. You can put any x you want in there, and it stays true all the time. So an identity is always true. In grade 11, you proved several trigonometric identities. To do so, you use some simpler identities. Let's do a little review of the identities that you have available in our toolbox, Trig toolbox. And I'm going to put them all on this page here again, but I suggest that other sheet because you're allowed that other sheet for tests and exams and so on, so you always have that available. And each one of these on here is a little mini identity that you can use to try and simplify the identity you've been given. So there's the reciprocal identities. Cosecant is 1 over sine. Secant 1 over cos. Costan is 1 over tan. You got those available to you. So they're potential weapons that you can reach out and grab during an identity question. Now you got all these. Tan is sine over cos. Cotan is cos over sine. The Pythagorean identity, sine squared plus cos squared equals 1. At other times in the course, I've thrown those in there and talked about them a little bit. Now we have them available. And any time along the way, if one of these is bothering you and you're like, where did these come from? Just skip me to sidetrack and I'll talk about each one. For now, in this particular lesson, we're going to use these as facts. Tan x is always equal to sine x over cos x. Cotan x is always equal to cos over sine. Now, sine squared plus cos squared equals 1 can be changed into these forms just by dividing the whole thing by either sine squared or cos squared. We won't use that too much, but I mention it because it does come up in later courses. It does come up in calculus that sometimes we want to take this and transform it into cotans, cosecants, tans, or secants just by dividing it by something. Okay? Won't come up too much, but I'll mention it. Oh, then all these that came up. Addition and subtraction formulas, double angle formulas, and all these ones, which I suggest to memorize, the ones on the left-hand side there. Only because things are going to go faster for you if you spend the time having those memorized. When they come up, you can just blast your way through them. Well, technically, I gotta tell you, in high school, we were forced to memorize these. You didn't get given these on a test. And it was good and it was bad. It was bad because you had to memorize. Yeah, I get that. But it was good because when they were in your brain, all the homework went faster because you weren't constantly looking them up all the time. And so it was a bit of a favor, something to think about. Even if you started memorizing them and started having a couple of them in your brain ready to rock and roll, it would make your life a lot easier. Okay, the key to becoming adept at proving identities is perseverance. You just can't approach identities like other homework questions. The idea of regular homework questions is that I explain it in a way that you go, oh, I get that. And then when you go to do the homework, you go, oh, I got this. I remember how to do this, and you practice it and you get good at it. Identities really won't work like that. Identities are going to be a challenge every step of the way. Every single identity is going to be this little mini challenge. And you got to sort of stick with it and play around with it. But I can give you some weapons. I can give you some weapons of how to approach the questions. Here are a few strategies that are commonly used in proving trigonometric identities. Move from the complex to the symbol. Let me rephrase that. Yeah, because I'm not sure if that really is a perfect explanation. So here comes some rephrasing of these ideas. And maybe some addition, you know. So this is the part maybe, I don't even know if I'd copy it onto that sheet. Maybe on a separate sheet, you want to write down these few little hints from Mr. Todd that says, hey, these are some good weapons that you're going to want to use to attack identities. The first strategy I suggest is do the complicated side first. And this is going to scare you, what I'm going to write next, is I'll put a question mark there. Because these aren't rules I'm suggesting. These are just strategies that are out there. Most times, it makes sense to do the complicated side first, but not always. So that bothers people. They want math to be like, oh no, do this, then this, then this. Well, identities just don't work that way. You just have a list of strategies that you can try. 2, express all functions in terms of sine and cosine. Now, that's pretty good advice. Let me rephrase it. If there is any sine or cosine make them all sine or cosine. Once you start doing them, this makes perfect sense. You go, well, if there's any sines and cosines in the question and I want to make these two things equal, it makes sense to go all sine and cos. And you can always do that. You can always use these identities that you have here to go all sines and cos. 3. Don't underestimate sine squared x plus cos squared x equals 1. That is a powerful identity. In fact, anytime there's a squared in the question, you can reach over and highlight this one and go, oh, this might be involved. But it has 2 little brothers that are very helpful as well. And those little brothers are just the rearranged versions of that. Sometimes you want to use sine squared x equals 1 minus cos squared x. And sometimes you want to use cos squared x equals 1 minus sine squared x. The next one says express all functions with the same argument. Well, I've never used that word before, by argument. So let me rephrase that and say this is what they mean by that, getting the same argument. See, these ones are all sine x, cos x, tan x, secant x, cosecant, cotan x. And in previous homework, actually, in the addition formulas, it was always about getting it down so that the angle inside, called the argument, was just x. And so when questions have sine of 2x, sine of x plus y, we probably want to get rid of that stuff. Probably. Scary that I keep saying probably, right? It's like, so there's no rules here? No, not really. Just guidelines on how you might approach these things. The 5th thing I'm going to mention here, and there's other strategies. I want to focus on those 4 strategies for now. The 5th strategy I want to mention is practice. No section in math, probably up to now, it's more important to just practice these and try another one, try another one, try another one. How much practice? Well, you know what? If you look in the homework, I provided more practice than you can probably do. I made a nice list. I'll show you on D2L at the end. I made a nice list of ones that I think, hey, if you did this much practice, you'd be in great shape. But there's like a million. There's a supplementary list there that has like 65 of them or something like that. I don't think I've ever taught anyone who's done them all. That's not the point of having that practice there. The practice is there to just say, I better do a lot of practice on these. Now we're short on time, this quadmester. I get it. We have to try and do what we can here, okay? There shouldn't be any questions now because this should be sort of mysterious. It's like, what are you talking about? Well, I'm going to do 3 examples and try and take my strategies for a test drive here and show you what I mean, okay? Which you don't have to copy down. You got the notes, the completed note. It's all sitting there. You can go look at that later, okay? First one, prove that 1 plus cos x is equal to sine squared x over 1 minus cos x. For all x values. We want to prove this is always true. So the proper form is to go left side, right side, and draw a line right down the center, and I'm going to draw the line way over here because I can see something maybe that you can see already, is that one of these sides there's not much work I can do on really. And then work down until I get to a line that shows that they're both equal to each other. Lots of opportunities for part marks here. You know, that's the nice thing about identities. People get really scared of identities because there's usually on the test like 2 4-mark identities, like 8 marks of identities. But most people can do a few steps anyways. You know, so there's not as much on the line as it might seem. So the left side is 1 plus cos x. The right side is sine squared x over 1 minus cos x. And I hope you can agree that the right side is way more complicated than the left side. It will be easier to turn the right side into looking like the left side than the other way around, because what are you supposed to do with this? It's so simple on the left side. In fact, there's not much to do on the left side, and that's why I left so little room over there. Okay? So, let me go through some of the rules that are blasting through my brain as I look at that. One of them that came up in grade 11 a lot was get it all down to sine and cos. That was one of the big things you're supposed to get out of grade 11, was get it all down to sine and cos. This one's already down to sine and cos. So that's not really going to help me on this one too much. However, there is a squared there, that's sine squared. And sine squared often, when you see squared in there, it awfully screams at you to think about the Pythagorean identity, which I said don't underestimate. So I'm going to go back and highlight that. Don't underestimate this stuff. Powerful stuff. You've got choices here. If you see sine squared plus cos squared, you can write 1. In some really advanced tough problems, if you see 1, you can write sine squared plus cos squared. If that helps you, it's a wild move, but it's possible. But also if you see sine squared, you can write it as 1 minus cos squared. And if you see cos squared, you can write it as 1 minus sine squared. And that's big here because this side's only coses. A really deep level of thinking here is to go, if this side's only coses, sine's got to go. Like, if they're going to be equal to each other, sine just cannot survive this process. And so if you look back on that Pythagorean identity, one of the little brothers there was that sine squared is equal to 1 minus cos squared. And that's sort of a happy step, because now both sides are only cosines. Okay? The next step is tough. It's tough to see what has to happen next. But I will throw in another strategy here. We used to say, if you don't hurt your neck when you're doing identities, you might not be doing them right. You should be spending a lot of time looking back and forth between the two sides going, what do I got, what do I got, what do I got? So maybe there's a little hint here in the 1 plus cos. You see 1 minus cos there. Maybe not. Maybe you have to see this first. So let me put this over here in another color here. That 1 minus cos squared factors. It's a difference of squares. How handy is that? That's why I said don't underestimate this thing, because it replaces sine squared, but not only that, what's left factors nicely every time into 1 minus cos x and 1 plus cos x. So watch out for that. You can almost see it coming after doing a few of these. You can see that 1 plus cos x over there, and you're like, oh, that's part of the factoring of 1 minus cos squared. So then when I go back over here, the numerator becomes 1 minus cos times 1 plus cos, and then just stare at that for a minute and enjoy what's happened, because something big has happened right there. Do you see the numerator and the denominator there? There's a factor in common of 1 minus cos and 1 minus cos. So those cancel. Use blue there. Gone. And I'm left with just the 1 plus cos. Therefore, left side equals right side. Therefore, true. Now, I don't know. Identity people, we write stuff like this all the time. Real short form down. You know, I probably should have said, therefore, I have proven that for all x values, the left side equals the right side. Therefore, this identity is true. I mean, that would be really properly writing it out. But we try and practice so many of them, we don't hold you to that. We're like, it's more important to do more identities than get hung up on exactly what you say at the end. So sometimes you just see people at the end, therefore true, next question. You know, and they just zip on to the next question, okay? But that's the proper form to finish this out. Is there any questions about that first example? I've thrown a lot of weapons at you in a hurry, you know? Like, so there's a lot of weapons to sort out here. And actually, this lesson's designed to have only a few examples and then a lot of practice. Reminds me of riding a bicycle a little bit. You watch me do it and go like, oh yeah, seems pretty easy. You really got to try it yourself. You really got to go and attack some of these questions before you really see the difficulties. Let's try another one. Oh, yeah, here we go, right in. You know, this is just off the charts more difficult than a grade 11 question. Cos of x plus y times cos of x minus y apparently is equal to cos squared x plus cos squared y minus 1. Woo! I'm going to draw my line over here this time. Left side, right side. Some crazy algebra coming here. Okay, this side here, I'm not really sure what to do with that side. To me, that's the simpler side, so I'll just leave it over there. This is the side that's really complicated. And if you don't agree, let me draw your attention to the argument, a word I haven't been using much of. And I'm going to underline the argument on both these. There's the argument of each of those. X minus y is what's the angle inside. And over here, it's just an x and just a y. See, this is nice. Nice arguments there. Very simple arguments. One single variable inside the cosine or sine. Whereas these ones have crazy arguments, and that might be the number one priority. If I go back to my list that I made here of all these strategies, maybe I'd like to change this to number one. Yeah? In grade 12 identities. If you see arguments that aren't just x and y, that usually is the first priority, is to deal with that. Because these cos of x plus y's can never come down to this until we deal with that. That's just never going to happen. So then you got to go back and you got to find on your trig toolbox the identity for cos of x plus y. I'm going to put it in a big bracket here. It's cos x, cos y, minus sine x sine y. Now, I didn't go look it up there on purpose because I wanted to show you the advantage of having those things memorized. If you've got them memorized, your life will just go quicker. But you don't have to. You can go back every time and go, okay, cos of x plus y, cos x cos y minus sine x sine y, and write it out. Then, the other one is cos x cos y plus sine x sine y. Easy to despair at that point and go, are you kidding me? Like, because it's a big giant mess. And it's worse than that. I got to foil this yet. Because that side has brackets. This side doesn't have brackets. Like, it's going to be this times this times that, this times that, this times that, all the way across. And actually, concentration becomes the main problem, is to focus enough to write the whole thing out and get it right. So here, you're going to hear me go quiet as I try and concentrate enough to get these terms right. Cos x cos y times cos x cos y is cos squared x cos squared y. Now, one more thing. In the middle of doing these identities, you can't just sort of stop and go, oh, that can't be right. It's not over here. Because you just don't know what's going to happen next. So you just have to have some faith here and punch these through a little bit. Next term, cos x cos y times sine x sine y is, sine x sine y cos x cos y. And you're like, are you serious? Look at that mess. Watch what happens next. It's so good. Yeah, this is like the worst moment in the question. Like, there's no way. Yeah, I can't make it. And then the very next term is sine x sine y cos x cos y, but with minus. I'm going to put it right beside it. Minus sine x sine y cos x cos y. This kind of stuff happens in identities all the time where you're like, this giant mess, which you're like, this can't be right. It can't be right that this term exists in all this. And then meanwhile, the very next thing in the FOIL was like, yeah, the algebra was like, yeah, I know it can't exist. Here comes the other one. Boom. And then my final term is minus sine squared x sine squared y. And things do improve at that point. These two terms cancel out, and I'm left with this mess. Still a mess. Cos squared x cos squared y minus sine squared x sine squared y. And you take a breath and you go, well, I'll enjoy the moment anyways. As bad as that was, things just improved. But now I want to talk about a big idea that's not all that complicated, actually. In grade 11, it was supposed to be like, if you saw tan, get it to sine over cos. If you saw cotan, get it to cos over sine. You got secant, I get everything to sines and coses. But an idea I want to plug away at in these examples is, this over here was all cosines. All cosines. And that should draw your attention, like, if this is going to work out, I got to get to all cosines. And this started off as all cosines. And then when I plugged in and did some work, I ended up with some sines. It's like screaming at you, get rid of sine. And the only way to get rid of sine is that sine squared term. And if you look back here, again, the Pythagorean identity keeps popping itself up. Sine squared is 1 minus cos squared. So whenever you see sine squared, you can replace it with 1 minus cos squared. Ooh, I need to do some scrolling down here. So I'm okay with this, apparently. And you have to have faith because this looks like trouble. It just looks like it's impossible that this could ever go away. And how can that, cos squared x, cos squared y, how can that ever come out to them adding together? But hey, I'll just continue on and get my part marks and hope for the best, right? So then, sine squared x is 1 minus cos squared x. And sine squared y is 1 minus cos squared y. So I'll multiply out those brackets with a negative out front. 1 times 1 is 1. And faith starts to come back just a little bit. Yeah? So if you want to be really upset in the middle of these questions, that's fine. But just make sure your head's on a swivel where when something good starts to happen, you're like, ooh, that's fun. I'll move that back up there for a second. 1 times 1 is 1. Then I get negative cos squared y. I'm just multiplying out the brackets here. Oh, yeah, starting to happen. Then, okay, where was I? 1 times 1 is 1. I'm getting distracted here. 1 times negative cos squared y. Negative cos squared x times 1 is negative cos squared x. Now, come on, you've got to be happy at that point. It's really close. I mean, it's not the right, none of the things are the right, they're all the wrong sign, but all right, that's all right. I'll worry about that in a minute. Back to here. Last term. Negative times negative is positive, so this last term is cos squared x cos. I'm really unhappy with this line in my way now. Excuse me. I want to write that really small. Cos squared x cos squared y. Close the brackets. Still looks like big trouble. But I still got a negative outside of this. So let me deal with that negative, and then we'll look at what we have. So I've still got this annoying cos squared x cos squared y minus 1 plus cos squared y. You see I'm just distributing the negative on all these. Plus cos squared x minus cos squared x cos squared y. How nice is that? Yeah, that's when you stop and you order a pizza and you go, Mom, I'm coming down for dinner now. It's done. Yeah, you can totally see it all. Doo-doo. Those go. And just to be fancy, I'll write it in the order they got because this is in the wrong order, right? They did the one last. Okay, so, and they did the x's first. Cos squared x plus cos squared y minus 1. Therefore, left side equals right side. Therefore, true. The biggest battle here was faith. That's why this example was chosen. The algebra is tough, but I think the biggest opponent in this is having some faith that things can work out. But I remind you again, as you're battling through these in your homework, to not completely freak out, especially if you did a whole bunch of steps, but you just can't finish it. Well, then you're probably 3 out of 4 marks or 3.5 out of 4 marks, right? So they're actually good like that, where you know, well, I'm going to get something done. I got a whole page of things I can do. So I'll get something done on this question, yeah. So finishing them? Well, finishing them sometimes can be a little bit rough. You miss one little negative or one little positive or one little distribution thing and it just won't work out. And that's why having friends in this situation and working with them is good so that you're not, on your own having an identity crisis. Thank you, Grace. One last one, really. One last one, and then really your time is much better spent trying them yourself and then checking with me or checking the solutions and so on and getting some hints and battling your way through. Okay, here we go. Very tough one. Left side, right side. this side sine of 2x over 1 minus cos 2x. And this side 2 cosecant 2x minus tan x. This is a great example because it's got a host of problems. It does two things. One is it's really complicated. But two, it also shows, well, you'll get some part marks. You'll be able to do something here. There's lots of things to do here because it's not really clear which side's more complicated here, actually. You could argue either side, I think, is very complicated. So you can sort of choose. So what do you see? Take a look at it and tell me, what do you see that maybe has to happen? There's at least two things I think that should be screaming out at you at this point that have to happen if this is ever going to play out right. Do you see one thing that has to happen? One thing we have to deal with? Max, what do you see that has to be dealt with? Yeah, the tan's got to go. Tan's got to go. Yeah? Over here is just sines and coses. It's like the left side screaming, we're only sine and cos today, folks. And so the right side's like, okay, yeah, I can switch over to sine and cos. Because you can always do that. What else do you see? That was a good catch. Now the way he phrased that allows me that there's still two more things that have to be dealt with in all this. Derek, what do you see? Cosecant's got to go. That's the second of the three big ones that has to be dealt with. And then there's one more thing that has to really go, has to be dealt with in all this, new to this grade. Okay? It was something that didn't come up in grade 11. It's these 2x's inside. This is never going to work out until we deal with those. But the nice thing is we've got formulas for those. So I'll start dealing with them one at a time. You know, I'll plug away at this, okay? Sine 2x, if you go to your trig toolbox, is 2 sine x cos x. I am trying to show off a little bit to show how much faster things can go for you if you got them memorized. You know, like you don't have to be flipping back and forth. At the same time, if you have the page up in the top corner when you're doing these, you can still go along. This one's a little interesting because cos 2x has 3 choices on your sheet. Now, I need to tell you, any of them will work. You just might cost yourself an extra step. That's all that would really happen. There's not one that's like wrong. But see, this one is sort of a hint. 1 minus something. Yeah? So to be a little faster, I'm going to choose the one that's got a 1 in it. Because then it'll be 1 minus 1, and the 1 will be gone. Won't that be nice? If you choose the wrong one again, I'm telling you, it's going to cost you an extra step. That's all. No big deal. But I like this one here. And let me explain why. Because when I put in cos 2x equals 1 minus 2 sine squared x, where is it? 1 minus 2 sine squared x. Do you see how it's going to be 1, subtract 1? And that's going to really simplify things in a hurry. In fact, I'm going to keep going on this because I've got some momentum on the left side and knock this side down. 2 sine x cos x over 1 minus 1 plus 2 sine squared x. And see that 1 minus 1, by seeing that coming, I was able to simplify things down even more. And so I get 2 sine x cos x over 2 sine squared x. Oh, well, that's pretty good. Actually, things can simplify even nicer. The 2's can cancel. And one of the sines can cancel. Yeah? So this sign goes with, that's not a squared anymore. It's just down to one of the sines. And you can show extra steps there if you need to think it all out. And I think I've done all I can do on that side, down to cos over sine. Tempting to go to cotan, but in the way we're doing this question, I wouldn't do it because we're trying to get everything down to sines and coses. And I think I've done all I can do over there. Do you see what I mean about part marks, though? There'll be things you can do, even maybe if you couldn't finish the question. Okay, over here, 2 cosecant 2x. So we agreed that cosecant had to go. So this is now 2 over sine of 2x. And tan has to go. That's sine x over cos x. We also agreed that when it's 2x inside, that has to go. And this example ends with a nice little piece that wasn't really mentioned in the opening part is, if the one side is 1 fraction and the other side is 2 fractions, common denominator is common. And at some point, you're going to have to add those 2 fractions together to make it all happen. So here, my common denominator is 2 sine x cos x This one already has that denominator, but this one over here, and I'll write this extra step in here, I've got to multiply the top by 2 sine x and the bottom by 2 sine x to get the right common denominator. So what I get here is 2 sine squared x. And let's say that was all as far as you could go. And if I was marking it and it was out of 4, I'd definitely give you 3 and go, oh, you really did wonderful on that. So it's not quite as scary as it might look. But if we want to finish this off, we need one more move. Way back in grade 11, they were supposed to be hammering you on common factoring, because common factoring came up again and again and again as an important strategy. And sometimes it wasn't costly, and sometimes it was. But moving forward now into the rest of calculus, if you don't common factor things every time you see them, it will be costly. Because if I common factor a 2 out of this top part, it immediately becomes something that we're going to have to get good at recognizing. That 1 minus sine squared. Almost screaming at you. When the sine squared was there, you're like, ooh, it might be a Pythagorean identity here. Or it's little brothers, right? Back to here. So I've already highlighted it once. Maybe I'm going to highlight it again. Highlight it, switch colors. Now I'll highlight it in red to go, hey, this is important stuff. Simple, I think. Simple stuff, but important stuff. Back to here. Back to where? There I was. I keep doing that right on the side there. Okay, so now this can get replaced with cos squared x. And then some cancellation. The 2's go. One of the coses goes. And it's cos x over sine x. Therefore, left side equals right side. Therefore, true. In those 3 examples, I think I've covered almost all the strategies that you'll see out there. Not all of them, but almost all the strategies at least. In what order do you do them and how do you handle them? Well, that'll change in every single question. It's a challenging pile of questions that you have to deal with. Any questions on that last example, though?